Hi everyone, Chris Rogers from Eco Engineers, and I'm here to show you about the organic waste to biogas ABC CAT model. Each model is built with 4 different sections: the applicant information, which helps define the project specifics, the user dashboard input, a summary of the calculation, as well as the eGrid maps showing the different eGrid subregions. So here in the user dashboard input, we have food waste to biomethane production inputs, food scrap feedstock, urban landscaping feedstock, and organic waste, biogas production and upgrading inputs, process energy inputs, user-defined electricity, transportation distance, carbon capture sequestration, thermal use, CNG to LNG production inputs, and then CNG to LNG user-defined electricity, as well as digestate usage. So the main differences between this model and other models currently out is a few additional things that biogas put in that revolves around user-defined inputs. As you can see, there's 3 feedstock buckets that we provided: food scraps, urban landscaping, and other organic waste. For food scraps and the urban landscaping, we're using the emission factors for the CARB Tier 1 simplified calculator. But in the other organic waste, we allow a lot of different things to be used. The type of organic waste, we provided a drop-down that gives a lot of different estimates on what the waste could be. All of these emission factors are based on the California 3.0 model. We also provide a user-defined to calculate the user-defined avoidance based on the CARB methodology. So we ask for a degradable organic carbon content, and then the fraction of degradable organic carbon that decomposes. So we also include a default value of 0.5, diversion rate, and then the rest of these have a distance and a amount to help calculate the CI score. So we think with this ability, any organic waste should be able to be calculated, and it's a much more straightforward approach. One of the other changes in here is we provide a user-defined mix for grid electricity, as well as a user-defined emission factor for natural gas. Try to do in the calculator is provide grayed out areas for things that don't need to be filled in. But when they do need to be filled in, for instance, by selecting user-defined on the natural gas, you'll see that this is populated, providing the user an ability to populate that user-defined natural gas emission factor with their own value. We also make sure to show default values that are all based on the GREET 3.0 model, so that you know the reference. So if this is on default, that 7.4 number that you saw before, that's the value that's being used. We also, during this work with ABC and the release, was in the middle of the transition, so we've included the GREET 4.0 emission factors for electricity, as well as the drop down for all of those. Additionally, we've also included a user-defined mix that generates the CI score based on a percentage of fuels that you're using at your facility. Also included transportation distance. This is for trucking upgraded biomethane to the injection site. So we can put user-defined, provide a user load capacity, truck efficiency, and then with these things, we're able to calculate that transportation distance. Also have carbon capture sequestration. This is either a default value which is based off of 97.5% capture rate and an electricity impact to provide a default value. Or for user-defined value, users can enter the amount of CO2 that's captured, as well as the sequestration energy use. This energy use should be different than the process energy use put up above in this row. Lastly, we have a digest state usage. Digest state has a couple of different dropdowns. The first is saying if it's used as to displace fossil fertilizer or not. So you can see here that when it's collected no, the areas that you don't need to fill in will be grayed out. If you'd like to displace your fertilizer with the digest state, we provide an ability to the volume of the digest state that's sent. We also provide a user-defined class characteristics for displacing the digest state, as well as class A and class B to give default values for those things. This is the main differences and the main changes on the organic waste to biogas model. Thanks.